Good morning, Year 10s. Do you know what? Honestly, a new contender. Honestly, the only reason why I enjoy doing these lessons is the fight that you guys have over getting in on the chat first. It's just brilliant. Like, I just absolutely love it. I really do. It cracks me up every time. Well done to Julius. Shout out to Julius here. It's just brilliant. Like, I just absolutely... Let's get rid of that. There we go. Yeah, well done to Julius. One commendation there, Julius, for getting in first. Oh, I love this. I love Callista saying, okay, this is a scam. Oh, I just love it. I just absolutely love it. Jack's now, of course. Jack, I love you too, Jack. You are the person who fights for my likes. I love it. Thank you. Keep fighting. Let's see if we can get everyone to do a like. Right. So I'm gonna crack straight on, guys. I'm gonna pop out the chat so that way it's not using any of my bandwidth. Let's pop that out and close that one there. There we go. So my chat's still there. I like it. Okay. So, and I'll switch my camera over to my clip cam. What's up, everybody? Thup. One dislike. Oh, makes me sad. Okay, so we're up and running. So Year 10. So and here are my learning objectives. Look at that, straight in. This is unacceptable. Okay, so I'll find my pen. There we go. So today is chemical tests lesson 5, and this is gas tests. So 3 learning objectives, try to keep them as short as possible. Number 1, know the gases we can test for. Number 2, know a method for each gas, and then know your observations. Nice and easy today, all knowledge-based. We realize that chemical tests, apart from the equations, which can be quite tricky, and they're the level 8s and 9s of this particular topic, the majority of these are a method question, and we do need to work on learning these. Chemical tests is all about learning. You can't make them up, you've got to know them. And I know that students often struggle with that. It just takes practice. Okay, so let's crack on. So the first thing is, what gases can we test for? So let's put gases to test for. Gases to test. Number 1, carbon dioxide, CO2. Number 2, I think everyone already knew that one. Number 2 is oxygen. It's nice for me to do the reminder of the pairing. Yeah, this is the formulae. Yeah, this is the formula. And then the name is oxygen. If you ever have an element that ends in gen or -ene, it is in a pair. Good way of remembering it. So we've got oxygen. Next, I'm trying to delete that. There we go. Number 3, hydrogen. So it's in a pair. Yeah, we can test for this guy too. Number 4, ammonia gas, NH3 gas. I'm actually going to put their state symbols on as well. I'll even add the words in as well. Why not? So we've got carbon dioxide. We've got oxygen, ends in gen, so it's diatomic. Hydrogen, so it's a diatomic. Hydrogen. Hello, gone Yorkshire. Hydrogen. Ammonia. There we go. Got to know ammonia, special gas, very important gas. One of the most important gases in the history of mankind. So important. And I actually believe that those are all the gases. Oh no, there is another test we need to add here, which is not a gas test, actually. I'll tack this on at the end of the... I ought to do a lesson on other tests, really. That'd probably be useful. Because I need to add water in here as well. We haven't done that one yet. And the test for water is so important. And also purity. So I might tack this on to next lesson. Since we've got one more lesson before your test, tomorrow's lesson, I'll add in all of those oddity tests that you got to learn. Yeah, that's probably a good idea, that. Do you know what? Whilst I'm here, I'm going to forget, you see. So I'm going to add that in down here. This is going to be iGCSE Chem Tests Lesson 6. And these are the extra tests. And that will include water, purity. How do you test something's purity? Alkenes. What else do I want to add? Do I want to add anything else to that? No, I don't think so. I think that'll do, but I'll add those. I'll definitely do with you next lesson. Okay, so only 4 gases to test for, which is super nice. This makes things a whole lot easier. Now, you guys know that there are loads of other gases out there, but we just don't bother to test for them, at least certainly not at GCSE level anyway. You pick up, you don't really pick up any other gases, to be fair. Even when you step into A level, you don't really collect any others. So let's focus on these. So first thing we're going to do is, we're going to do a method. Yeah, and what we realize we do is we have a generic method at the beginning, which then gains detail at the end. So method for gas test. See what I did there? See what I did with the G state symbol? So writing the word gas again. So the first thing is, and this is like one of the most lost marks when they talk, when students do gas tests, because they kind of just cut the beginning off, because you must say, collect sample of gas. Collect sample of gas. Now, most of the time, I'll actually write the word gas there. Collect sample of gas. Now, most of the time, and I need to talk about this collection because there's an issue here. Because some gases, like hydrogen, so this is collect sample of gas. So hydrogen is the lightest gas there is. So if you have a balloon filled with hydrogen, it'll float like a helium balloon does, but it's actually light. It's actually twice as light as helium, amazingly. And hydrogen gas, what that means is if you make hydrogen gas, so for example, if we make hydrogen gas, let's say I have in here hydrochloric acid and I add a piece of magnesium. Let's add a piece of magnesium here. Metal plus acid, let's write the equation for this. Metal, so let's do equation. Metal plus acid, and all acids are aqueous. I'm going to get, guys, do me a favor, pause the video, complete the equation if you can. That would be wonderful. Pause the video, complete the equation. So the final product is magnesium chloride, which is a pair. It is MgCl2, and it's going to be aqueous because it's a salt, so it's going to be dissolved in the water. And I'm going to form a hydrogen gas, 2 of them. So this is metal plus acid goes to salt and hydrogen. MASH. Gotta love MASH. Invented by one of my year 12 students. Well done, Zaina. Well done. So impressed. I hope people got the formula. That's, of course, quite a tricky equation, that, because this guy, of course, is Mg2 plus for magnesium, because it's in group 2 on the periodic table, and Cl minus, cross and down, 1 magnesium, 2 chlorines. In reality, it's about charge, but it's fine. So what we're going to see here is we're going to see bubbles. This is going, oh, tap to set up your pen. All right. Uh-oh. Okay, just going to ignore you. We're going to see bubbles, and this is going to generate hydrogen gas. Now, what we're now going to do, in order to collect it, what I'm actually going to do is put over the top of this, I'm going to put a test tube, and that test tube is going to be full of water. And what will happen is the bubbles will actually go up into the test tube, and it'll displace the water. Yeah. Now, just to let you know that this method is called fluid displacement. This is upward delivery, brackets, fluid displacement. We're displacing, we're pushing the water out the way. That's what displacement means, to replace. We're replacing the water with the gas. This is upward delivery. You could alternatively, there is another method for this. There is another method here, which is if you, the other method would look something like this. You could do a boiling tube with the HCl in it, and then you could add in your magnesium ribbon, like that, Mg. It's going to fizz. It's going to produce lots of hydrogen gas. And then you put a delivery tube on it. Oh, don't really need to do that, do we? Problem is with this, you have to go quite high. Didn't like that. It's a gas jar. Oh, really big, tall gas jar. There we go. And what will happen is, there we go. So the hydrogen that we're going to collect is going to fill up the top of the jar up here, and it'll just push out the air out the bottom. So you can also do that way as well, because the hydrogen's lighter than air, it'll remain and just fill it from top down. You don't get a particularly good sample of hydrogen because there is still, it's going to be mixing with the air all the time. You're not going to get a very pure sample. This is but this is again upward delivery. Yeah, because it's upward delivery because it's lighter than air. But it can be done, it's just not as good. Impure sample, impure H2 sample made. Whereas this one, because the water removes all the air from the tube, this one's going to give you a much purer sample. Purer sample since air already removed. I'll show you all of these on my YouTube video when I'm back at school on Friday. Purer sample since air already removed, because the water's removed it. Right. So that's hydrogen. So we collect sample of gas. And by the way, that's what they'll do is they'll often draw, if they want to ask you about these methods, they'll usually give you the diagram and ask you to explain why it works. And the key thing here, so people often think, oh my God, do I have to learn all of these things? You don't. They're going to give you these diagrams, but the nota bene here, I'll shrink my pen a bit. The nota bene here is they'd like you to know the term upward delivery. Upward delivery. Learn that. That's worthwhile. And the next thing is, why can you do this? Yeah. So the first bullet point is upward delivery because H2 is less dense than air. Less dense than air. That's all you really need to know. You don't really need to know these methods. They'll give you these diagrams if they want to ask you about them. So you don't need to worry about learning the diagrams. But we collect a sample of gas. Now, if we've got a sample of gas, what would that actually look like? You can imagine a little test tube with a cork on it. Yeah, and inside here is my gas sample. Right. Now, and by the way, that's generic for all of them. Once you've got your sample, now each one is going to be individually tested. So, collect sample of gas. Let's say it's hydrogen, H2 gas. Right, now what we're going to do for hydrogen gas, the test is light, I'll stick to black. Light gas on fire using a lit splint. What does that look like? It looks like this. You take the cork off the test tube. The hydrogen gas, of course, will start trying to escape because it's very light. So what you have sitting there is you have your splint, which is on fire. Yeah, your splint, which is on fire. There we go. And then what you're now going to get, you probably all remember doing this in year 7. You do this test in year 7. and you're going to hear the observation. Observation is a squeaky pop sound. Done. So there's hydrogen. Nice and easy. I'm going to move that word sound under here. Squeaky pop sound. It'll go, whoo. Yeah, we did this in school and we heard the pop sound. Amazing. Right, gas number 2. Okay, so we're going to collect our sample of gas. Let's do carbon dioxide. Carbon dioxide gas. Now, carbon dioxide gas is not done through upward delivery. It's done exactly the opposite. It's done via downward delivery. So again, if I have a boiling tube, and if I want to generate carbon dioxide gas, I'm going to add an acid, HCl, and then I'm going to add a carbonate of some variety, probably calcium carbonate. Let's write the equation for this. Calcium carbonate. This is actually the test for a carbonate ion. Plus acid goes to, guys, can you complete the equation, please? And don't forget to balance. Yeah. There we go. Complete the equation and then balance it. Pause the video, have a go, check your answer. Unpause when you're ready. So I'm going to form calcium chloride salt, and the salt will be aqueous. It's a tricky one, that, because once again, the calcium is a +2 ion from the group 2 on the periodic table. The chloride ion, of course, is 1-, crossing down, just like magnesium. Yeah, so CaCl2, but I'm also now going to get carbon dioxide, and I'm also going to get water. So I balance it there with a 2. Carbon dioxide is going to come out as a gas, and the water will come out as liquid water. We did it with you too. Oh, you did? I do remember this. So there's the equation. We're going to generate some carbon dioxide gas. Going to get lots of lovely bubbles of gas. Going to see some lovely effervescence, if you can spell it. And then what we need to do is we now need to collect it. Now this is downward delivery. This is downward delivery. So in this case, because the gas is heavier than air, what I'm going to do is I'm just going to collect it, putting the delivery tube to the bottom of the container. And of course, what will happen is the CO2 will drop to the bottom of the container and it'll push out the air. Yeah, this is downward delivery. Downward, I'll do it in red. This is called downward delivery. Once again, not very pure. It's going to mix with the air. It's going to have a low purity. But we don't really care. It'll work. Yeah, if we wanted to do the pure version, we'll do the same thing. We'll do if we want a pure version, HCl, calcium carbonate, but this time I'm going to deliver this underwater. Yeah, I'm going to deliver this underwater. There we go. And this will go into a water bath, a water trough. And then over the top of that will be my test tube, which is full of water, because we're removing, and then the bubbles, of course, will just. Now, there you go. This works because the carbon dioxide and hydrogen are both less dense than water. Well, we know this because water is very dense. But in terms of gases, you have to do downward delivery versus upward delivery of the hydrogen. It's nice to recognize the two different gases are very different in their behaviors, but the same method for fluid displacement is always the same. I know I did a funny diagram, but by doing it that way, that was just, you wouldn't do that. You'd put it in a boiling tube and add a delivery tube and all that jazz. Okay, so now how do we test for carbon dioxide? So carbon dioxide, I'm just going to shorten the splint there. There we go. So for carbon dioxide, what we're going to do is we're going to take our sample of gas and we're going to bubble it. So same step number 1, collect sample of gas, and then the second bullet point is bubble through lime water. You've got to, I cannot lime water. My students, year after year after year, lose that mark because they miss this. It drives me bonkers. You cannot miss it. Yeah, the bubble through, you've got to have it. Year after year, they forget. Observation, I should just put observation, lime water turns cloudy. I hate that. You can say cloudy. You can say milky. Hate every single one of those. Milky. Or you can say what I prefer, which is a white precipitate formed. White precipitate formed. Just to give you the equation for that, which I know we've already done, CO2 reacts with lime water, which is calcium hydroxide. Just to explain to you how I've built that, the calcium is a +2, the OH1 minus ion, the hydroxide ion, crossing down. You need the bracket because people often do that and you can't because that means there's only one oxygen, but you actually need 2 of those entire ions. So you've got to put it in a bracket. So there's calcium hydroxide or lime water. And what it's going to form is limestone. Limestone and water. And limestone, of course, is a solid and it's white. And that actually balances amazingly. Right, so we've done CO2, on to the next one. Okay, next one is oxygen. Yeah, next one's oxygen. Sample of gas, collect a sample of gas. If you're wondering with oxygen if you would do upward or downward, the answer is pure oxygen has an MR of 32, and the air is slightly less than that at about 31, slightly less, maybe 30. So technically oxygen is more dense, but it's almost exactly the same as air. So you'd always collect this underwater. There is a problem with that, which is if you collect it underwater, you're going to lose a lot of it because oxygen's very soluble in water. You're not going to lose a lot of it. You'll lose about, I don't know, 1/5 of it. It'll dissolve into the water. I'm happy to show you that again when we get back into school. Anyway, so how do we test for oxygen? Bullet point number 1, collect a sample. Yeah, bullet point number 2. Using a glowing splint, place at mouth of sample tube, observation, glowing splint will relight. So what this looks like as an image is test tube full of oxygen. We did this, I think, again. And you put in the mouth of the tube, you put a glowing splint. It's not lit this time. It's not lit this time. It's just glowing. It's kind of glowing with a slight yellowish color to it like this. It's glowing. And then what you do, and then what will happen is it will immediately relight in pure oxygen. It'll immediately relight. So the splint will all of a sudden just relight on fire again. That's what will happen. There we go. It'll relight. Okay, last gas, ammonia, Nh3 gas. Right, now ammonia, annoyingly, has 2 tests. I know, it's a pain. Yeah, ammonia gas has 2 tests. So the first one is collect a sample. We always start with that. Collect sample. You don't need any more details. By the way, ammonia has an MR of 17, it's light, so it will rise. So this is going to be, by the way, just to tell you, explain where the MR comes from. Nitrogen on the periodic table weighs 14, So this is the mass number. So it has a mass of 14. Hydrogen is 1 and 1, so its mass number there is 1. And ammonia is a nitrogen atom bound to 3 hydrogens. So if you add up the total weight of this is called the relative, we've done this before, of course, relative molecular mass, and the total for this is 17. So what that means is it's much lighter than air. By the way, air has a relative molecular mass. It's an average because it contains 78% nitrogen, 21% oxygen. So it's about 30, give or take. It's actually more like 29. So anyway, much lighter. So that means collect sample. We're going to collect it via upward delivery, upward del, because it's lighter than air. So now that we've got our sample, let's draw the picture. Got our sample of ammonia gas. Right, what we now need to do is we're now going to put into the mouth of the test tube damp. So place at mouth of test tube damp red litmus paper. And observation, and yes, you have to have it damp, it'll turn blue. Obs, turn blue. So the damp red litmus paper, damp red litmus paper will suddenly turn blue at the end. That's what will happen when it's in the presence of ammonia gas. So that's test number 1. That's the primary test. There is a second test that you have to know. So alternative. The alternative test is collect sample of gas, place near mouth of test tube, concentrated hydrochloric acid, HCl. The whole thing turns blue? No, it's just the end. Does it only turn blue at the ends? Yeah, only at the end where the gas is hitting it and where it's damp. Now, what's going to happen? Observation, white smoke. Okay, so this is actually the test. You take a test tube and you've got your ammonia gas. And then you take another test tube, and this test tube contains a small amount, terrible diagram, contains a small amount of concentrated hydrochloric acid, conc-HCl. Now, what's actually happening is the hydrochloric acid turns into hydrogen chloride gas, HCl gas, and the ammonia gas wanders up this way as well. And what happens is they come together and they hit together. You guys did this in diffusion, and what you form is white smoke. What you form is white smoke where these things come together. Just to show you the equation of that, the ammonia gas reacts with hydrogen chloride gas. You wouldn't call it hydrochloric acid because it's not an acid, because it's now a gas. Acids are only acids when they are in water. And what's going to happen is you form ammonium chloride solid. They combined. We did this. This is what you do in that stupid big long tube. Do you remember that big long tube I did a long time ago? And at the end of the tube, I put a piece of cotton wool soaked in conc ammonia, concentrated ammonia solution. And then on the other side, I put in a piece of cotton wool soaked in concentrated hydrochloric acid. And you form a ring here. You form a big white ring there. white ring of smoke. And the reason why it forms closer to the HCl is because the ammonia, which has an MR of 17, MR of 17, and hydrochloric acid that has an MR of 36.5, because it's lighter, that's 1 mark, by the way, in the exam. Because the ammonia has a smaller MR, it means it travels more quickly. This question is imprinted on my mind. It comes up a lot, Zina. Like EdXL are obsessed. Really weird, by the way. No idea why. And they say it diffuses more quickly and travels a greater distance in the same amount of time. I know. Honestly, I can't explain why EdXL is so obsessed with it. I don't know. I think it's because they think it's cool. I don't know. It is quite cool. It's fun. Anyway, so the same equation's happening here. So it's another test for ammonia. You could actually argue, by the way, that that's also a test for hydrochloric acid gas. There's another gas test. You could test hydrochloric acid gas with ammonia gas, which is quite nice. That actually brings us to the end of gas tests. That brings us to the end of gas tests. So I'm not going to waste your time now, guys. I'm just going to head straight back to here. So what I'd like you to now do, we've now finished our gas tests. So I set you a homework on the classroom. You have 20 more minutes in lesson. Can everyone now have a go at the homework sheet I posted on the Google Classroom and try and finish it off before the end of the lesson? That way you have no homework. I will see you guys tomorrow. One more lesson, extras, an exam question review, test on Tuesday. I will see you guys tomorrow. Have a great day, guys. Bye.